Mattias Skold. I'm a senior lecturer in composition at the Royal College of Music in Stockholm, and also pursuing a PhD at the Royal Institute of Technology in Stockholm, with a focus on interactive notation and compositions. So the challenge that I'm addressing with research is the distance between electroacoustic music and acoustic score-based music on a conceptual level. This feeling that maybe students feel they have to take sides, and those are electroacoustic people and those are not. And I dabble with both fields, so I feel that they have more similarities than differences. I think this divide is partly due to music theory discrepancy, that you perhaps use different vocabulary for the same things. So the question is, can we find common ground in a shared system of music representation? The idea being to develop a hybrid notation system that combines traditional notation of pitch and rhythm relations and electroacoustic music analysis notation, starting from spectromorphological analysis notation by Thoresen and Hedman. So this is the Thoresen and Hedman notation system that maybe some of you are familiar with, and some of you maybe don't too well. It was developed based on, say, Schaffer categories, and then developed into a sort of usable graphical analysis system with graphical notation. And of course, they had to make great adaptations to the Schafferian categories in order for this to work on a more sort of objective level. And of course, for me, in order to use this from some sort of composition perspective, I had to make further adaptations. But the starting point was to use much of the Thoresen symbol framework, because it was a tried system. It had been used successfully to actually describe interesting sounding structures. And incidentally, I talked to Thoresen about this idea, and he was not very interested in using this notation for descriptive music. He's much more into phenomenological approach and describing what you hear. But he was nevertheless keen to be able to find out from his endeavors. So you would take these kind of symbols from the Thoresen system and place them over staff systems. And the first adaptation then would be to include symbols of spectral width, which are the dashed vertical lines. Mind you, there are indicators of spectral width in the Thoresen Hedman. It's just that they are indicators, and I need something that shows on the graphically, okay, what is the width of a noisy sound? Because that is, at least from my perspective, what is interesting, what would be interesting, for example, in an algorithmic composition situation, where I want to assess what is going on in terms of spectrum. And then we have the possibility of using traditional notation of rhythm. So the idea being that if you bring in things that are usable from the terms of describing pitch and rhythm from traditional notation, but also use all the tools from describing sound structures, that possibly one can have a system that doesn't lack in one certain kind of music, meaning that we could have electroacoustic music that suddenly has elements of harmony, or at least interval relationship. And it's not just going to be represented as two frequency values where you have to sort of do the math in your head to decide what kind of, okay, what is this interval? When using this with students, of course, I had to instruct them, okay, where do we place the symbols on a staff system? So we made this sort of rough instruction that, okay, for pitched sounds, it's pretty simple. You take the root frequency of any spectrum, of a harmonic spectrum, and that's where you place the sound, just like any traditional notation. But for the dystonic category from Thoresen Hedman, which is basically clusters or inharmonic spectra, you would try to decide what is the loudest partial. And then, of course, you could notate other partials as well. And for complex sounds, the solution I found was to use the spectral central. And for the students working with this, and I will come back to this, basically I advised them to use the channel EQ logic, because it has these wonderful spectral analyzers that just instantaneously tells you, okay, this area, this is where this noise is. So we tried this, I tried this with my students. So I have a course I've been running for a long time, many years, where I've actually been working with torus notation already, but with the analysis system, and not with a staff system as a backdrop, but more describing what you hear. But nevertheless, they had to compose with it and do other things with it and analyze. So I used that course module in order to try this system out, to see, like a first run, to see, okay, what results did we get. And what I hoped to learn then was if there could be some sort of agreement in the interpretation of the symbols, if there were aspects of the notation system that were particularly hard to grasp for the students. They were all composition students, bachelor students in the first year. Some were electroacoustic composers and some traditional or classical or Western contemporary. We have weird category naming and stuff. Western art music. And where the problems occur when analysis notation is placed over a fixed time frequency grid. And where the problems occur when new symbols are combined with traditional notation. And then finally just a sense of what kind of results you get, what is it relevant artistically to work in this way. So the first student assignment I did like this. I made a short excerpt of a piece, and I used just the kind of sound files that those of you who are working with electronic music, you will probably have these kind of folders with sounds that never enter into a piece, but that are there, and maybe you're even more. And I just picked a few of those sounds and made a little short excerpt, 60 seconds. I notated it using this system, and I handed the score to the students, not playing back the original music. Just saying, okay, can you realize this score using only concrete sounds that you find around? Record whatever you have in your surroundings, and try to realize this score. And in my original, I had been combining electronic stuff with seagulls and other sounds, and the original sounds like this. All right, so here we have a combination of electronic stuff and some noises and some pitched sounds and a few glissandos from seagulls. Here is then a superimposed version of all the students' examples of realizing this with concrete sounds. So when listening to all the different examples from the students, we've, at least in the group, agreed that what we heard could be at least considered to be through different interpretations of the same piece, which was a fun discovery. The problems following this first assignment, well, first classifying sounds and their energy articulation, so deciding what is what. That is always difficult for first bachelor students, particularly the ones who have not worked with electronic music at all, because they were not necessarily used to thinking about their work in that way. Which means that even in former runs of this course, there will be it takes time for students to grasp the concepts of dystonic sounds and harmonic spectra and what is this and what is that. So it's hard to assess if that has to do with this. It's probably something that will always take time if you sort of encounter it for the first time. But anyway, that was one of the problems in terms of consistency and correctness in terms of notation. New symbols combined with traditional notation caused some confusion, not necessarily the wrong rhythm, because as you heard of the superimposed version, the rhythm was quite accurate from basically all the students. But they were sometimes confused because I used just the rhythm, like the stems from traditional rhythm notation. And sometimes I didn't know, am I looking at some novel notation approach now, or is this just a stem? Because it's a line, I don't know what this line means. So some confusion was there. Conflicting information, and that had to do with, because in this course module they learned about analysis, and they had tools to get on. So they would look in that article and find things that were not necessarily in tune with how I had advised them to work. So there was some confusion there. And then there were musical features missing, meaning that there's not any talk about dynamics in it. And I had not. I just told them to find some solution of their own because it was not part of the project at that time. But that was what created the greatest discrepancy in terms of different interpretations. So modifications, I simplified and I said, okay, just work with the core parameters from the tools analysis, the core categories. That was one simplification. I used small non-textual partials. And this was to use rhythm notation on a separate staff system, so you are not confused once you see traditional notation combined with sound notation. Also, I used a more detailed frequency scale to help in deciding, okay, where should this noise be placed? So a more detailed frequency scale as well. And the second assignment was a composition assignment. Some days they were given free hands, just use notation, use complete sounds again. And these were just like blank score paper that I handed people that they could use. And some wrote by hand and others wrote. This is an excerpt of a sound object made by one student. It combines different objects in one gesture. Another example. And although I would say that the students were, I think, more interested than before because they felt that they were on the development of the notation system, which meant that they were more active in talking about notation in this round than they had ever been before, because they felt like they had a say and had plenty of suggestions for dynamics and different solutions, which was fun because it became more engaging in that sense. So the conclusions then, I talked about the agreement in interpretation, and the fixed time frequency grid, working with the staff system in this case, helped, because then you had a sort of common ground. You knew that, okay, you could go check and analyze the sound and see, no, that is actually. So that helped in having some sort of a common ground. Aspects hard to grasp, I covered that. That was the sound spectra thing, which still takes time to get used to. Problems with analysis notation over a fixed time frequency grid. What happens when you move the analysis system over a fixed grid like this? And many elements of the original analysis tool had to remove one by one to realize, okay, this has to be more of a new system. And yes, there was some confusion whenever you combine the old with the new, and that was to be expected. And as for the sense of artistic relevance, it's hard to say just one run with a few students, but based on previous experiences of this course module, there were more students afterwards who were talking actively about using it in their composition work. And then moving to current work and future work, I'm now in the process of bringing this into the computer so that I can work algorithmically with the notation and generate notation and stuff like that, which is under construction, and also sort of having a corresponding MIDI style language that sort of becomes the data representation of the notation. So that's part of it. So I think algorithmic composition has been very successful thanks to the sort of MIDI language correspondence, which becomes some sort of universal, nice numeric way of sort of saying this is the data. It can be notation, it can be a simulated sound. And all in all, and also I should say that spatialization will also be included with this in the future, but I have not got around to working with it yet, but it will be part of it, particularly since we have this very nice spatialization dome now and stuff that you're welcome to come and visit. So thank you.
So we have time for a few questions. Yeah.
Hi, thanks for your presentation. I was wondering, when you said students were ready to use them in their composition, and when you said you're thinking about a system of using algorithmically, then I suppose you have a synthesis method then to implement the process and to review all the results.
The idea is to have this sort of like you would work with MIDI or notation with other music, that is becomes sort of the structure of it.
So your idea is that the piece is the score, and then everyone can implement it in another
sort
exactly as one can play the visual.
Yeah, sort of. Yeah, I mean, the next step in terms of composition will be I'm working with a violinist, but then I imagine you have the sound notation on one stuff, and then together with the violinist, knowing these are the results we need to make. Then we can decide on these instruments how to create those noises with those bands.
I have another question, if I can, very quickly. You talked a little bit about the issues also about this, and you said the lack of dynamics, for instance, the lack of the lack I feel the most is the lack of, at least from what I understood, the lack of timbre. Which means when I take a violin piece, I write violin, and I suppose that the C actually represents a violin C of some sort. And in the example you gave of your students, it was kind of nice to hear that they actually took some of the notes as bells, little bells, where you took them in a very different way when in the original piece. And that's a big difference. I don't think this is I wouldn't call it a sort of interpretation of a piece, because it's very different if I do that with a bell or with an harmonica, for instance. And how would it be possible to account for that? Or
I never thought of the system as something that describes perfectly. I think of it sort of the way that traditional notation is so limited, and particularly when you break it down to MIDI, it's just pitch and velocity and nothing more. Okay. And still you can sort of make the skeleton of like a Bach fugue or something, and then you can sort of bring it to life. And I think the frustration is that, for example, in the acoustic works, is that when you have like a Lachenmann piece, the notation says very little of what you hear. So even this limited kind of notation still is going to account for more of what you hear than what the Lachenmann clefs is going to tell you, because that's the action.
Okay, yes, thank you. Yeah.
So time for another question.
Yeah, thank you for your presentation. How about sort of the timeline and the time continuum? So things like rhythmic complexity. I don't know if I was just wondering if your system, or if you intend to address sort of like, you know, the unique kind of particulars of rhythm in electronic music.
I want to be super pragmatic about this, which means that I think why traditional music works so well even now is because people feel free to adapt it to whatever needs they have. And I feel like you could move from second notation to rhythmic notation. And my point just being that certain kinds of material, even if they appear just for 3 seconds in a piece, is much more suitable to be represented in terms of rhythmic notation, perhaps, than seconds. For example, the seagulls in the examples, which, if you see the rhythm notation, you instantly can get sense of the rhythm. So the idea being that, like in Logic Pro, where you can go between different views and see the material in the way that's best used the material.
So let's thank our speaker again.